Hey everyone, it's Ben from Board to Bits, and welcome to part 9 of our series on making a custom 3D model in Unity. So, currently our cube script is just kind of dumping this raw vertex data that we have into our mesh, and it's always going to create a cube around the origin point, the 0, 0, 0 point in the world. In addition, it's always going to be of a size of 2 units by 2 units by 2 units. In order to use this kind of cube and put it into a voxel system such that these cubes will respond to data in a data set that we have, we need to be able to scale them and to position them where we want them. So we're going to start by scaling our cube. And we're going to do this, we're going to open up our procedural cube script in MonoDevelop. Open it up here. And the first thing we're going to do is up in our variables up here, we're going to create a public variable, public float, and we're going to call it scale. This is, much like it sounds like, going to be responsible for handling the scaling of our cube. I'm actually going to set it defaulting to equal to 1. Now, the other issue is that currently, if we don't mess with the scale at all, if we were to keep the scale at 100%, we're getting this 2-unit sized cube. So really what we want to do is have that to start so that when we do a 1 scale cube, it's 1 unit by 1 unit by 1 unit. We can do that pretty easily. We're just going to, by doing this, we're going to create a second float, and I'll actually put it up here, called adjusted scale. And then the first thing we're going to do we'll actually do it in the wake function, we're going to set the adjusted scale equal to scale times 0.5f. So it's going to, whatever the scale is, it's going to be halved so that our scale is dealing in raw units for us instead of double that size. The next thing we can do, in our start function, we're going to want to give that scale to our make cube function. So what we can do is we can simply put in here adjusted scale. Now obviously our make cube function isn't asking for a parameter, so we need to make sure we do that. We're going to add in here float, and we're just going to call this, we won't call it scale because that's going to conflict with this one up here. We'll call it cube scale. So now all that the make cube, we know right now all the make cube method is really responsible for is creating these lists and then passing off information to the make face method, which can then actually make the faces of the cube. So we're just going to continue with that idea, and in addition to passing the direction of the face, we're also going to pass our cube scale. Now once again, we need to make sure that our make face method wants that float information, so we'll say float face scale. And last but not least, we can make sure that when we are adding this range of vertices data, these face vertices, we are also again passing in a float or face scale information. So now we need to jump over to our cube mesh data, because now we're going to actually tell the cube mesh data, hey, those 4 vertices that you're getting right now, we need to adjust them based on this scale. So in cube mesh data, remember we are creating an array of 4 vector 3s, and right now we're taking the raw vector 3s from this array based on the position in the vertice, the face triangles array. So if we're on direction north, we're getting the 1st, 2nd, 3rd, and 4th vector 3s in here. So, but that's again just these positive 1s and negative 1s, so it's giving us that 2-size cube. Instead, we need to now take all this information, and the nice thing is that we can multiply the entire vector 3 by the scale float, and it will know, and it will affect all 3 of those points of information, the x, the y, and the z of the vector 3. So we're going to put in our parameter here, we'll put float. This one we can just call scale, not going to conflict with anything. And we can just make sure that when we get this vector 3, we can also multiply it by scale. So with all that done, we can jump back over to Unity. No method for face vertices takes one argument. But I'm passing it to... Oh, that's why, because I passed it in the wrong location. Need to make sure we're passing that inside of the actual face vertices call and not the add range call. Okay, now we jump back here. There we go. So if we go to our... Oh, I'm still calling this procedural grid from when it was our grid model. We can actually change that. Let's change that to procedural cube now. Save our scene. And now we see we have this scale information here. We'll zoom in a little bit. So this is the 0.000, and then these are -1 on the z and x, +1 on the x. So this is one unit. This space here is 1 unit. So now what we should see is a single unit cube that forms kind of, you know, halfway to any of these lines. We'll hit play, and there it appears. Now what we can also do is we could say something like the scale should be 0.75, 3/4 of a unit, and the cube gets a little bit smaller. In fact, if I go up to our Y view and go isometric, we see that that's only, yeah, about 3/4. It's not quite to halfway around these edges. However, if I were to double the scale again, we see that it becomes the whole size of the, filling up all 4 units here. Going, you know, from 2 units across, 2 units in depth, and 2 units in height. So that's all good. Now we are able to scale our cube. I'll set it back to 1 here. Now positioning is a little bit more involved, only because we can't just simply say, oh, pass this position, because we have to respect that scale. And that's why I started with scale, because the position is going to be affected by the size of these cubes. For example, if there's a cube that you want 1 to the left of your origin cube, but your scale is only 0.6 in size, you don't want it to be the whole unit away, you only want it to be 0.6 away. But we can do that relatively easily. Let's jump back into our procedural cube script, and we're going to create 3 public integers. I'm going to call these position x, position y, and position z. And we'll see in Unity that those all will appear here. And we wanted these to be integers because when we're dealing with voxel information, it's going to be like an array of data points, and so those are going to obviously have index values as their positions in that data set. So we want to make sure that we're dealing with round numbers here. So we could change this to something like 1 on the x, 2 on the y, and -3 on the z, or anything that we wanted to. I'll reset them for now. But now what we're going to do is, we're going to, when we go to make our cube, we're going to pass in an actual, a vector 3 of information that's going to be the actual position based on the scale and how we're changing that. So this is, again, relatively easy to do. I'm going to say here, in make cube, we're going to ask for a vector 3 called cube POS, cube position. Now, in the same way that we made this adjusted scale, we can't make the adjusted, we could make the adjusted scale, like we could make an adjusted vector 3 here, but that's not really ideal for us because chances are our position is going to change on like a loop, like we're going to loop through an array of information and that position is going to change with each iteration. So we don't really want to make it a set position right in the awake function. It's probably going to happen when we're calling the cube. So let's do that here. Instead of calling it in awake, we're actually going to make the vector 3 right in our make cube call. So we'll say new vector 3, and this is going to be equal to position x times scale, or times adjusted scale, position y times adjusted scale, and position z times adjusted scale. Now, I believe this will naturally cast these to floats, but just to be sure, let's make sure that they're cast as floats so that we're not accidentally rounding our scale if we don't want it to be. So with those now we're going to be telling our cube to appear in the position in a integer-based position, but then adjusted for the scale of our overall cube and our overall voxel system. We're calling for vector 3 cube position here. We'll once again add in a parameter here. We'll say cube position. And so we'll need to make sure that the make face is asking for that as well. So we'll say vector 3 face position. And when stuff starts tabbing on you, you know that you're missing probably a parenthesis somewhere or a semicolon, and it looks, oh yes, over here. Need to add one more there so that we're enclosing our full make cube call. So we are asking for the vector 3 cube position, passing it into our make face method, which is asking for a vector 3 face position. And then in the same way that we added our face scale, we'll pass in our face position. And we can simply jump back over to cube mesh data. And now here, we're actually I'm going to put this all in parentheses because that's a self-contained, this is the vector 3 kind of within the cube. This is where that vector 3 should be. And now we're going to add to that, we're simply going to add the additional vector 3 of our position, which I need to add up here as a parameter. So we'll say vector 3 POS for position, and then we can simply add that here because when you add two vector 3s together, it just simply moves to the kind of cumulative location. We save that. Now we come back to Unity. If I hit play right now, it'll be a evenly scaled, 1 unit scaled cube right at the origin. So not really any difference here. However, if I were to move this on the x-axis by, say, 1, we see that the cube is only moving half a unit. So I have... Oh, I guess we just want to multiply this by scale. Interesting. That was my mistake. I had assumed that we would want to adjust the scale on these, but because we're moving it by the that's surprising to me, but we'll try it out this way and see how this goes. So now it moves the full unit. And if I make this to scale 0.5, yeah, it only moves half the unit. Okay. Oh, that's why. That's because because we're basing it on the origin of the cube, we only want the vertices to go half the distance from point to point. However, we do want the actual cubes themselves to move the full distance, so that you have kind of two halves of a cube between the centers of the cube, so the cubes are touching. Apologies if that's a little bit of a clunky way of saying that, but that does make sense, and as it turns out, that we do want our positions to be the full kind of quote-unquote double scale, whereas the cube itself is being built based on this half scale. So, with all of that done, we are now successfully moving, and here, I'll do another here. We'll say this is 0.25, move this up to like 4, and we see it moves 4 divided by 4 times 0.25, which is it's 1 away. So that's all working. So now that we're able to scale and move our cubes as we want to, we can actually kind of pass in a set of data that will tell our cubes where to appear dynamically and create this sort of a voxel system that lets you create dynamic landscapes or other dynamic objects based on a cube system of 3D modeling. So thanks for watching. We'll dive into that in our next video, and I'll see you next time.